For the final section on trigonometric functions, we're going to talk about reciprocals. So we're going to take the sine, cosine, and tangent functions, and we're going to talk about reciprocals of those. So hopefully you recall what a reciprocal is. So if you know the value of sine theta, how can you find cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta? That's what all those letters mean. So our objectives are to evaluate reciprocal trigonometric functions and then graph them. I hope you're ready. It's going to be fun. Okay, cosecant, secant, and cotangent. That's how you spell those. The cosecant written as CSC, the secant written as SEC, and the cotangent written as COT. They're not sk, sec, and cot. Just like they're not sin, cos, and tan. They're sine, cosine, tangent. This is cosecant, secant, and cotangent. They're defined using reciprocals. They're undefined when their denominators are 0, just like with any value. So cosecant is 1 over sine, so it's our reciprocal of sine. Secant is 1 over cosine, so these, they're easier to remember because they're opposites. So cosecant starts with a C, so you think it'd be cosine, but it's actually 1 over sine. Whereas secant starts with an S, so you think it'd be sine, but it's actually 1 over cosine. And then cotangent's the easiest. It's 1 over tangent theta. Alright, so finding values geometrically. What are the exact values of cotangent negative 5 pi over 6 and cosecant of pi over 6? Do not use a calculator. So we're going to go ahead and use our unit circle, which you should have memorized by now. If you haven't, you need to get on that bandwagon, like ASAP, because you are going to have to know it, and you're going to have to learn it. It's going to become your new best friend. So when we want to find cotangent of negative 5 pi over 6, if we were to draw the unit circle, negative 5 pi over 6 means that we're going in a negative direction around the unit circle. I'm going to draw here a unit circle. So we're going the negative direction, and we're going 5/6 of the way. So this is this value right here. So for this one, hopefully you have learned your sine and cosine values. This is negative 3 pi over 2, negative 1/2. So to find cotangent, it's 1 over tangent of theta. Remember, tangent is sine over cosine, sine theta over cosine theta. So what do you think the inverse of tangent is? Well, it's going to be the opposite. So cotangent is actually cosine theta over sine theta. So our cosine value is negative square root of 3 over 2. We're going to put that over negative 1/2. So in order to find what our tangent or our cotangent value is, we need to multiply by the reciprocal in the denominator. Oops, 2 over 1. Multiply at top, negative 2 over 1. Those cancel. Our negative becomes a positive. Our 2's cancel, and we get square root of 3. So the cotangent of negative 5 pi over 6 is square root of 3. Fabulous. Alright, there you go. There's all that again. Ta-da! Okay, for cosecant of pi over 6, remember, cosecant is 1 over which one? Well, it starts with a C, so we would think it would start with a C, but it's the opposite, so it's 1 over sine theta. So our value of pi over 6 on the unit circle, we're moving in a positive direction, and pi over 6 is this value right here, and our coordinates are square root of 3 over 2 and 1/2. Okay, so for sine theta, sine is the second value in our unit circle. You remember that our cosine theta, sine theta, our x and y values are coordinates. So we put 1 over 1/2, so multiply by 2 over 1. Those cancel, so we get 2. So the cosecant of pi over 6 is 2. So that's how you find these geometrically. You use the unit circle, you simplify, get rid of irrational denominators, do all those fun things. Oh, that one's there too. Alright, if you want to find values on a calculator, most often I will not have you do this method, just so you know. But this is another thing that you can do so you can check and make sure you got the correct values. What's the decimal value of each expression? Use the radian mode on your calculator, so make sure you go to mode and it's set for radians, and then round to the nearest thousandth. So the first one is secant 2. So when you look, there is no secant button on your calculator, so you have to actually know what secant means. Secant means 1 over, starts with an S, we think it'd be sine, but it's really not. It's cosine 2. So if you put 1 over cosine 2 into your calculator, 1 divided by cosine 2, make sure it's in radian mode, hit enter. It says to the nearest thousandth, you should get negative 2.403. Okay, so that's how you do that one. If you wanted to find cotangent of 10, cotangent is 1 over tangent, so you put in your calculator 1 divided by tangent 10. You get that value, plug it in. You get that it's about equal to 1.542. Make sure you're actually doing these and then checking to make sure that you got the same answer I did. Okay, and then if that gives to you in degrees, so before it's been assumed that it's been in radians. So if this one is in degrees, cosecant is 1 over sine. So we're finding 1 over sine of 35 degrees. You need to keep it in radian mode even though it says degrees, but when you put it in your calculator, you need to include the degree symbol. So put it in just like that, 1 over sine 35 degrees, end parenthesis, and then hit enter. And then you should get a value of, whoops, there we go. It's about equal to 1.743. Alright, hopefully you figured all of those out. If you had any problems with those, make sure you ask your partner when you do lesson check, or you ask me in class. I'd be happy to do those with you. I left this slide in here because it made me laugh, because my brain's a funny place and sometimes it makes me laugh even when I don't think of. Anyway, so I've been telling you all year I don't want you to be a monkey, but I just put on the slide. It's so easy a monkey could do it. You know, as long as a monkey knows their reciprocal trig functions, assuming that to be the case. Okay, for sketching a graph, what are the graphs of y equals sine x and y equals cosecant x in the interval from 0 to 2 pi? Now remember that secant and sine are reciprocals of each other. So when we graph them, they should be graphed as reciprocals. Okay, so what we're going to do is make a table of values. Since we're going from 0 to 2 pi, we know what sine values are for pi over 3, pi over 4, pi over 6, pi over 2, pi. So we know all these from the unit circle. So that's where all our values for sine came from. And I just had them put into decimal form, just so that it's easier for graphing purposes. And then cosecant is 1 over sine. So you take all of your x values that you have, or yes, your x values that you had for sine, and then you take 1 and divide it by that. So you see for the first one, we have no value because 1 divided by 0, you can't do, can't divide by 0, universe implodes and all those things. So that's why we have some missing values. What do you think those are going to be? They're missing values. Those are going to be asymptotes. So they're going to be lines that we approach, but we don't actually touch with our graphs. So when you graph these, so if we were to graph y equals sine of x, that's just a normal sine curve, amplitude of 1. There we go. From 0 to 2 pi, we have one complete cycle, so that's the blue line there. Now, what the red line is our values for our reciprocals. So can you see how the reciprocals work? So our curves are going the opposite direction, and then we have where it crosses the x-axis, these are undefined values because our denominator would be 0, so these become our asymptotes. We also have another one they didn't put on here. The first one that's on here is this value right here. This is also an asymptote. So this blue, it continues. The blue line continues going this way, but the red lines, they're bound into these asymptotes, and they're the curves that are opposite of the blue ones. So reciprocal functions are pretty fun. They make interesting pictures. Alright, we can use these for solving problems. A restaurant is near the top of a tower, and a diner looks down at an object along a line of sight that makes an angle of theta with the tower. So there's a picture. The distance in feet of an object from the observer is modeled by the function d equals 106 secant theta. How far away are objects sighted at angles of 40 degrees and 70 degrees? So we want to find if things are 40 degrees away or 70 degrees away. Well, if they're 40 degrees away, here our theta is 40, that means we're going to be looking down at things that are closer to the ground, so that's going to adjust how far away we're looking. Whereas if we're looking at things that are 70 degrees away, they're going to be further away over here. So they'll be further. So this is what we're looking at. Okay, so the first thing we're going to do is we're going to go ahead and put this function into our calculators. This d equals 601 secant theta. So go ahead in y1, put in y1, y equals 601. Remember, secant is times 1 divided by cosine x. Make sure you put all your parentheses in correctly. Okay, so you put that in as your function, and then you can graph it if you want, but we don't really need to graph it because we're looking for two specific values. So what I'm going to have you do is go to your table feature. You're going to plug in x is 40, and you get your value for y. So when x is 40 into this problem, what is my value of y? And then you're going to do again for 70. So when you plug those both in, you should get 785 feet away when x is 40 degrees and 1,757 feet away when x is 70 degrees. Pretty simple, not too complicated. Alright, here are your lesson check questions. I would like you to do these 3 questions. These are the first thing you're going to talk about with your partner when you get to class. And then your homework is to do the lesson 13-8 on MathXL, and then go ahead and start your practice test because we have a test coming up next week over chapter 13 so that we can finish out the last chapter on trig before the end of the year. Alright, hope you have a good night.